Okay, so last lesson, you could see we have this section up here where we looked at the logs, we looked at exponential functions, e to the power of x, and the derivative of e to the power of x is e to the power of x. And the antiderivative of e to the power of x is also e to the power of x. So let's look at these questions here, question 1, 2, 3, and 4. Question 1 and 2 are derivatives. So I'm going to ask for the derivative of question 1. So I'm going to put dy dx. Because if I've got y equals, I will use dy dx equals. So the derivative of 4 e to the power of 2x is 4 e to the power of 2x. So that's the first part. But then we have to multiply by the derivative of the bracket, and the derivative of the bracket is 2. Okay, now the derivative of 5x is 5, and the derivative of 3 is 0. So we don't have a value here, so we get a 0 for the constant. So we left with 8 e to the power of 2x plus 5. Okay, so that is the answer for part 1. Let's look at part 2. And now we've got the function of x. So if I want the derivative, I'm going to use f dash x. So that's the symbol for derivative. The derivative of 6e to the x over 2 is 6e to the x over 2. Now we have to multiply by the derivative of that bracket, which is a half. The derivative of minus 7x is minus 7, and the derivative of plus 8 is 0. The derivative of a constant is 0. We're left with half of 6, which is 3, e to the power of x over 2 minus 7. Notice we've just got minus 7, and plus the 0 is gone. What I'd like to do for question 3 is go back and have a look at the answer for part 1. 8 e to the 2x plus 5. Let's do the antiderivative of this. So the antiderivative of this is we leave e to the power of 2x. And because it's antiderivative, we divide by the derivative of that bracket, which is 2. Now here we've got 5x to the power of 0. So for the antiderivative, we raise the 0 up by 1, and we divide by that new power 1. So we raise, I'll just say that again, we take the 0, we add 1 to 0, and we divide by that new power of 1. Now, we've got this 0 here. We don't know what that number was. We'll just put plus a constant. So the antiderivative of 0 is c. Up here it was a 3, but we don't know what that number is down here, so we just put plus c. Yes, it's a 3, but we don't know that. Simplifying this, that 8 over 2 is 4 e to the 2x plus 5x plus the constant. So if you derive this, you will get 8e to the 2x plus 5. If you integrate 8e to the 2, if you integrate, I'll use the word integrate, or if you get the antiderivative, same thing. Get the antiderivative, you will get 4e to the 2x plus 5x plus c. Okay, let's look at question 4. And I just want to use the answer for question 2, which was 3 e to the x over 2 minus 7. And I want to get the antiderivative of that. So I want to integrate that. So if this is the derivative, then we antiderive that. We simply get f of x. So the integral of the derivative is the function. We don't change the first part, but the second part we have to divide by the derivative of x over 2. That's divide by a half. And 7x to the power of 0 is 7x to the power of, we raise the 0 up by 1 and we divide by that new power. And there was this 0 here. The derivative, the antiderivative of 0 is a constant. The derivative of a constant is 0. And simplifying that, 3 divided by a half is 6. E to the x over 2 minus 7x plus some constant which we don't know. In question 2, you saw the plus constant was a plus 8. The derivative of 8 is 0. The antiderivative of 0 we don't know. It is up here we know it was an 8. Down here we don't know what it is, so we just put plus a constant. So that's a few extra questions to stretch derivatives and antiderivatives of exponential functions. Next lesson, we're going to look at the derivative and antiderivative of logarithms.